Now we are going to see the language processing system. We already seen language process. We already discussed what is compiler and interpreter. So compiler role we already discussed. The compiler is taking the source program and it is translating into the target program. But if we have a source program and source program may be high level language, any of the high level language. From this high level language, how you are getting this target code? What are the different components are useful here? We are going to discuss one by one. Here the different components are, one is the preprocessor and another one is the compiler and assembler and the linker and loader. All these components are very much important at the time of translating the source program to the target code. See here the source program or any high level language code. High level language code we already discussed. So any of the simple instructions, so I am taking as the C language. The C language code you are writing in the starting, top of the source code you are writing some of the library files. So file inclusions you are going to write here. So the header files #include stdio.h, and one more is the macro expansion, that is defined pi equal 3.14, and after that some source code is there. So this complete you are calling it as the high level language code. In this high level language code you are passing to the preprocessor. So the preprocessor is going to include wherever this particular file inclusions required, it is going to include. So this particular source code is not actually it is divided into different modules. If you are writing a source code, C programming code, it means you are writing #include stdio.h, the defined pi equal 3.14, and you are writing the source code. What is the meaning of this? So in this source code you are just only mentioning the what is the header file only you are mentioning. You are mentioning here some of the macros, right? Here it means the library file is somewhere else. So whenever it is required you are going to taking inside the program. It is complete all these modules data it is going to collect by this preprocessor. The preprocessor role is wherever this particular individual modules are there, it is going to collect. So like for example here library header file is required, is taking and it is including here. In the source program this header file is required, it is going to include, right? And it is the macro expansion is there. Wherever this particular macro expansion, this particular pi equal 3.14 value is required, it is simply going to substitute in your source program. The preprocessor is collecting the data from the different modules and it is going to substitute wherever the file inclusions required, it is going to substitute, and wherever it is required the macro expansion, it is going to do this particular macro expansions also. And after removing everything, so the modified source program you are going to pass to the compiler. The compiler is taking the source code, that not exactly this is the source program, it is the modified source program it is taking. Modified source program is nothing but there is no #includes, there is no macro expansions. So without macro expansion, without file inclusions, so whatever the code is generated from the preprocessor, this code you are passing to the compiler. The compiler is taking it and it is translating into the assembly program. So here there is a doubt here. So here the compiler is there directly, you are expecting the target code. Why can't directly it is translating to the target code? So why you are intermediately you are generating the assembly program? So the reason is, if you are translating the code into the assembly program, so it is easy to produce the output. One of the advantages is you can easily get the output here, and the debugging process also so easy. So that's why you are translating it to the assembly language. Then in the assembly language nothing but here it is how exactly you represent the assembly code. It is in terms of the mnemonics. Mnemonic in the sense the different codes, like for example load. If you are going to do the move, you are going to use some of the registers. You are going to store the registers, and whatever the code is there, assembly code, you are passing to the assembler. The role of the assembler is it is taking the assembly program and it is going to get as output as a relocatable machine codes. What is the relocatable machine codes? So different pieces of the code is there. All the code is a different modules related code. You are going to get into one piece, so that you are sending this particular code into the linker. The role of the linker is it is going to link whatever the object files are there, what are the library files are there, what is the relocatable machine codes are there, everything it is going to link it, and it is going to generate one of the executable file. The executable file you are going to load into the memory. So finally from the executable file you are going to get the target code. So these are the different steps are there in the language processing system. Simply taking the high level code and you are expecting the target code. So in between you have to do in between there is a process of pre-processing process there, the compilation process there, then it is going to do the assembler role also there. So finally you are going to do the linking, then you are going to use the loader. You have to load all these whatever the generated file you are going to load, then you are expecting the target code. So this is the steps you need to follow in the language processing system.